Hello, Pre-Cal. This is a quick recap for graphing parabolas that we've been looking at in section 2.2. So just a reminder, we have two different forms. We have the vertex form where you can clearly see HK, and then we also have the quadratic form, which we'll need to use the vertex formula. So I'm going to go through both of those quickly in this video as well as a quick application. So if we have this function, f of x equals negative 1/2 times the quantity x minus 3 squared plus 4, we can see that our vertex is at 3, 4. If our vertex is at 3, 4, then our axis of symmetry is at x equals 3. Remember, if you want to know where the vertex is, or your horizontal shift for that matter, take that value, that expression, and set it equal to 0. So I'm going to utilize that axis of symmetry at x equals 3. Go ahead and put that in, and also plot the point that is the vertex. Over 3, up 4. Now, we also know that our a value here is negative 1/2. Since the a value is negative, our parabola is going to open down. Since our a value is 1/2, which is between 0 and negative 1, we know that the parabola is going to open up and be a little bit more wide at its maximum values. So those are just some characteristics that we can see based on the a value, the h, and the k. So from there, let's make a quick XY chart just to get a couple more points. Remember, I'm going after, I want to see 5 points plotted in order to have a pretty precise parabola here. So obviously, if we put in 3, we get 4. Now use the 3 and then either go to the left 2 or to the right 2 and go from there. If we plug in a 2, 2 minus 3 is 1. Or is negative 1. Negative 1 squared is 1. 1 times negative 1/2 is negative 1/2. Negative 1/2 plus 4 is 3.5. So over 2, up 3.5. So use the whole idea of the axis of symmetry. If there's a point here, then by symmetry there has to be a point at 4, 3.5. Let's plug in the 1. 1 minus 3 is negative 2. Negative 2 squared is 4. Half of that is negative 2. Negative 2 plus 4 is 2. Over 1, up 2, use symmetry again, 1, 2, 1, 2, and that is 1, 2, 3, 4, 5. That's the points we need in order to graph. Let's go ahead and find that Y-intercept because it's always a critical value. 0 minus 3 is negative 3. Negative 3 squared is 9. Half of that is negative 4.5. So that is going to be at negative 1/2. 0, negative 1/2, 1, 2, 3, 1, 2, 3. So now we've got a nice smooth curve going through those points, and that is our parabola. Now we're going to graph given a quadratic form of the equation, and when we utilize the quadratic form, first of all, let's identify A, B, and C. Our a value is the same a value that we saw here. It behaves the same way. So our a value is positive 2, which means this parabola is going to open up. And because the a value is 2, it means that it's going to be taller and skinnier. This is creating a vertical stretch. Our b value is 8. Our c value is negative 2. We're going to utilize the vertex formula, which is opposite of b over 2a in order to get the x coordinate. We're just going to find the x coordinate of the vertex. So opposite of 8 over 2 times a, 2 times 2, that's negative 8 over 4, that's negative 2. Now, there was some question of, well, what do I do with that? Well, it says f of opposite of b over 2a. So that means we need to find f of negative 2. So we're going to go to our function and we are going to evaluate the function when x equals negative 2. So f of negative 2 is 2 times negative 2 squared plus 8 times negative 2 minus 2. Please follow order of operations. Exponents first. Negative 2 squared is 4. 4 times 2 is 8. 8 times negative 2 is negative 16. And minus 2, negative 16, there we go, minus 2. So 8 minus 16 is negative 8. Negative 8 minus 2 is negative 10. Our vertex, which will be our absolute absolute minimum, because this parabola is opening up, our absolute minimum is going to be at negative 2, negative 10. So let's plot that point, which also means we're going to have an axis of symmetry going through that point. So we have an axis of symmetry at x equals negative 2. So from there, let's plug in some values, choose left or right. It doesn't make any sense to choose anything that far away because it's not going to fit on the graph. So let's go with negative 1 and 0. So let's find the negative 1. So plugging it in, negative 1 squared. I think I'll even write it just to not make a careless mistake. Here we go. Negative 1 squared is 1. 1 times 2 is 2. 8 times negative 1 is negative 8 minus 2. That is negative 6 minus 2. That is negative 8. And of course, when we plug in the 0, all we're going to get is our c value, because the rest of the polynomial is going to cancel out. So that's negative 2. So negative 1, negative 8, 0, negative 2. This parabola is much taller, much skinnier than the last one. I think we can get a 1 in there. That's going to be 2 plus 8, which is 10, minus 2 is 8. This will be 8 over 1 up 8. Tall, skinny parabola. 1, 2, 3, 1, 2, 3, 1, 2, 1, 2, and 1. Here is our parabola. Nice, smooth curve, not jagged, not pointy. That's what our parabola looks like given the quadratic form. Next, let's take a look at checkpoint 5 here. Checkpoint 5 says, an archer's arrow follows a parabolic path. The height of the arrow, f of x, in feet, can be modeled by f of x equals negative 0.005 x squared plus 2x plus 5, where x is the arrow's horizontal distance in feet. So let's go back. Let's highlight what we're given once again. The height of the arrow is f of x. That's the height. Then we've got x is the arrow's horizontal distance. So there's a horizontal distance going in. So this is the height in terms of the horizontal distance, f of x. The height in terms of the horizontal distance. So if you look at this function is simply a quadratic function. So f of x equals negative 0.005 x squared plus 2x plus 5. A is equal to negative 0.005. B is equal to 2, and C is equal to 5. Now, we could use the vertex formula. Let's do that, and let's find the vertex. So, opposite of B over 2A is negative 2 over 2 times negative 0.005. This is a good time to utilize our tool, the calculator, and find what we're looking for. Here we go. Whoop, clear. Trying to get to the right screen. There we go. So we've got a fraction, and it is negative 2 over 2 times negative 0.005. So here's our fraction, and when we evaluate, we get 200. So the x-coordinate of our vertex, x equals 200. That's what we got when we plugged in our B and A into the vertex. So now we're going to take this x-coordinate and we are going to evaluate the function when x equals 200. And remember, this parabola, which we really can't graph, it would kind of be a mess. It's just going to be, big, up in the air, way up in the air. Our x value of our vertex is at 200. So f of 200 is what we're going to plug in next. We're going to use our calculator again. Let's write it out. .005 times 200 squared plus 2 times 200 plus 5. So I'm going back to my calculator, which hopefully you can see better this time. So plugging in this expression to simplify. So negative .005 times 200 squared plus 2 times 200 plus 5, enter, and we get 205. So f of 200 is at 205. So that means my vertex is at 200, 205. Remember, this is my absolute maximum point. So I think we're able to answer that first question. It says, what is the maximum height of the arrow and how far from the release does it occur? So if my absolute maximum value is 205 and the x-coordinate is 200, and I probably should have drawn my parabola a little more like that because we're going from 0, starting at 0, and we're going to be finding another value over here. So right up there, there is 200, 205. So let's see. It says, what is the maximum height? So A, what is the maximum height? The maximum height is 205 feet. And how far from its release does this occur? It occurs 200 feet from the release. 200 feet from the release. All right, so there is A. What does B say? B says find the horizontal distance the arrow travels before it hits the ground, round to the nearest foot. So what we need to do is we need to determine, well, what is this distance? We need to determine this distance. So we need to find the zeros of this graph. We need to find the zeros of this graph. So if we're going to find the zeros, first thing I need is a fresh sheet of paper. And we know the vertex is 200, 205, and we need to use the quadratic formula. The quadratic formula, x equals negative b plus or minus the square root of b squared minus 4ac all over 2 times a. Everybody absolutely must know that. Because what this allows us to find, it allows us to find the zeros, and remember the zeros are the same thing as the x-intercepts of the graph. So once again, A is negative .005, B is 2, and C is 5. So x equals negative b plus or minus the square root of 2 squared, which is 4, minus 4 times a, be careful of the signs, times c, all over 2 times negative .005. This is going to yield 2 real roots because we're looking at this parabola and we're talking about an archer's arrow. These are real numbers. So what do we have? Follow order of operations. Order of operations says do what's underneath inside the grouping symbols first. So that's why we go to the radical first. I'm going to go to my calculator and I'm going to enter in exactly what's underneath the radical sign. 4 minus 4 times negative .005, close, open, 5, close. There we go. Underneath the radical, we have 4.1. X equals negative 2 plus or minus the square root of 4.1 all over. And then let's do what's on the bottom, and I call that the big fat fraction bar. It also is a grouping symbol. So on the bottom, we've got 2 times negative .005. That is negative 0.01. So we need the decimal approximation for 4.1. So let's go back and let's grab that 4.1 and let's raise it to the 0.5 power to get its square root. So negative 2 plus or minus 2.025, that'll work. And your calculator will continue to store that value and we can just grab it over and over again. So here we go. What do we have? We have negative 2 plus 2.025, negative 2 plus 2.025, which think about it, that's basically 0. And we are going to divide that by negative 0.01. Now, what do we get? We get negative 2.5. Now, why would that be negative? Why would that be negative 2.5? Well, that's kind of why we need to think about it. It's really a little bit over there because the y-intercept of this graph is essentially going to be the height at which the archer shoots the arrow. So visualize someone holding a bow and arrow and it's not exactly on the ground. That's why the original x-intercept is negative 2.5. So we got to find that, and then we got to do the other side of this, which is going to be, because we just did the plus, now we got to do the minus. So let's do that. So negative 2 minus 2.025 is that divided by negative 0.01. That is 402.5. 402.5. So if we are considering our x-axis, here's our x-axis. So basically, here is where the archer is when he pulls the bow back, which means if we were to continue our parabolic motion, it would be there, way, all the way across. And then we're all the way over here at 402.5. So what we've got to do is we've got to find the absolute value of the distance in between those two numbers. So if we start out potentially at negative 2.5 and go all the way across, so that is going to be, if we're thinking distance here, we would say 402.5 minus negative 2.5. That is a total horizontal distance. A horizontal distance of 402.5 plus 2.5 is 405 feet. 405 feet for a total horizontal distance in between the two zeros of this graph. And we're not going to graph this on paper. We would just take this graph to the calculator. So y equals negative 0.005 x squared and plus 2x plus 5. And we're going to take this graph, whoop, I got something wrong, back. Don't have anything wrong, I just had to go back and look at it. Think about that a value. It's so close to 0. That's why when we look at this graph, and if we can somehow zoom, and let's see, actually I'll change it this way. So let's change that x minimum to negative 3, an x max of 406, and a y max, our max value, think back, our max value was 205, and we'll put that y min as just a negative 1 so we can kind of see what's going on here. This is what the graph looks like. Think about it. It's an archer shooting an arrow, and we are zoomed way out in order to do this particular graph. That is what is happening in class today.